How do you create easy-to-maintain code, making your Java classes replaceable? Welcome, Java Challenger! By learning the principles of this video, you will be able to maintain your Java code more easily, and it will also help you to stand out as a Java developer. I'm Rafael Del Nero, a Java champion, and today I will show you the solid Liskov substitution principle. So let's first analyze the fundamentals of the solid Liskov substitution principle, and then we're going to go to the code. So it's important to remember that the core concept of the Liskov substitution principle is that the subclass must be fully replaceable, which means that the subclass can't be inconsistent with the superclass. So remember that, that's the most important concept. And then we have behavioral subtyping. So as I said before, we need to preserve the expected behavior. Then there is contract fulfillment. On preconditions, remember that the subclass can't have a stronger validation than the superclass. On postconditions, a subclass should not weaken the postconditions of the superclass, meaning that the behavior of the method can't be changed. It has to do whatever the superclass contract is saying that it must be done. So the subclass has to follow the contract. I'm going to show you those fundamentals in code to be more clear, but for now, just keep those concepts in your mind because we're going to explore them in code. And no new exceptions, which means that the subclass can't throw an exception that's not being thrown by the superclass. So now let's see the code examples to make it clear. Okay, so let's explore the concept of Liskov with the simplest example using the rectangle example. Remember that in math, a square is actually a rectangle. Okay, so this is the rectangle class, very simple. We have the width and the height, and notice that we are extending shape. Nothing special, we just calculate the area with the shape class. And we also have the square class, which is extending rectangle. Like I said, in math, this makes sense, right? But we're gonna see here in object-oriented programming that this doesn't make much sense. So let's check here why. So notice that in the main code, we are passing a width of 5 and 4, which is okay for a rectangle. This is correct. But then what happens is that when we instantiate square, we are passing only one number here, which is fine, which should be the right thing for a square. But then we can also invoke the setWidth method, passing a different width which breaks the contract of a square. A square should have the same height and the same width. And here this is not happening. Therefore, it's breaking the Liskov contract. So here we should be able to pass only one side, but then we are able to pass both attributes here. So this is wrong. It breaks the contract of a square and it breaks the contract of the Liskov principle. Now let's see an example using the Liskov principle. So let's start from the abstract class shape. So here we have the same method, getArea, and here in rectangle we extend the class shape and we pass the width and the height here, and we do the calculation correctly for the rectangle. And then for the square, we also do it correctly. So now instead of extending rectangle, we are extending the shape class. And now it's totally fine because we don't have the setters anymore. Now in the square class, we can only pass one side, which makes sense for the square contract. Now we can't create a rectangle anymore. We are only able to create a square because a square has to have the same width and the same height. So here, when we run this program, then it's fine. Here we pass the width of 5, the height of 4, and here we pass only one side for the square. Let's see another example with employee. So we have those two abstract methods, calculate payment and calculate bonus. We have the full-time employee, and here we have some logic for the calculate payment method and some logic here. We also have the part-time employee, but the part-time employee doesn't have a bonus. So again, it breaks the contract of the Liskov principles. So here it will throw an exception as well. Now let's see the same example using the Liskov principle. So here we have only the calculate payment method, and here the full-time employee extends employee, and we can calculate the payment. And the part-time employee, we also have the calculate payment method because both of them are paid anyway. So this example follows the Liskov substitution principle. Now let's see an example with payment, now not using Liskov. So let's start from the abstract class. So we have the process payment method and process refund, and then we have the credit card payment. And here we have the process payment doing some logic for the credit card, and here refund for the credit card, nothing special. And then here on gift card, we are processing the payment, but a gift card can't process refund. So we throw an exception, which breaks the contract of the Liskov principle because every class we extend from the superclass should have the same behavior. But if we don't have a refund in the gift card and we throw an exception here, that breaks the contract of the Liskov principle, meaning that we should be able to process the refund by using this class. Otherwise, it's not Liskov. And then it's just an example using those classes, and since this method will throw an exception and it's not able to process the refund, it's not using Liskov. Now let's see the example using Liskov. So it's a similar abstract class, payment, which has abstract method of process payment. And then here we should have some logic to process the payment with credit card and another one for gift card. And notice that both classes we are processing a payment. Therefore, it's not breaking the contract of the Liskov principle because those classes are substitutable. Both of them can process a payment. And here we have no exceptions. We process the payment for credit card payment and gift card payment. Now let's see an example with a precondition being inconsistent with the superclass. So let's start with this example. So we have this bank account class and we are doing a very simple logic here. We just check if the initial balance is negative. If it's negative, we throw this exception, and here we deposit some money to the balance, and we have the withdrawal method as well, doing some basic logic here. And then we have the saving account, which extends the bank account. And notice that here we are breaking the contract of Liskov. Why? It's because we are doing an extra validation here. So for the saving account, we have this validation where we must have the balance of at least 50. So since we are doing this extra validation, we're not following the Liskov principle contract. So we can't add an extra precondition. Now let's see an example now following the Liskov contract. So we have the same methods here. We have firstly the constructor. We have that validation to avoid negative numbers. We have the deposit, withdrawal, get balance, and then we have the student bank account. And in this class, we don't do any extra validation here. And here we also don't add any new preconditions. Now let's see an example with a post condition not following the Liskov principle. So on this example, we have the door lock class and we have the unlock method, which will change the is locked to false. And then after that, we're gonna unlock the door, and here we're gonna lock the door. So it's very simple. And here we have a timed door lock, which means that firstly, we're gonna unlock the door, then we're gonna put a timer of 1 second, and then we're gonna lock the door again. But that's not the intention of this method. So the unlock method should keep the door unlocked. But as you can see here, since it's a timed door lock, we are breaking the Liskov substitution principle. Why? Because this method is not doing what we are expecting. It should unlock the door, but here after some time, it will lock the door again. Now let's see an example using the Liskov principle. So we have the same class, door lock, and we have the same methods from before. And then we have the code protected door lock, which extends door lock. And here basically if you pass the right code, the door will be unlocked, And we also have the unlock method, and we have a small configuration here. So basically, if this flag is not enabled, then we're gonna unlock the door, which still follows the contract of the Liskov principle because it will unlock the door. But if the code is required, then we're gonna just log that. We're gonna log that unlocking requires a correct code. So remember the core principles of Liskov. Remember that a superclass must be fully replaceable by the subclasses. If there is any inconsistency with preconditions, postconditions, or if there is a new exception being thrown in the subclass, then it's not following the Liskov principle. So remember that sometimes we can't code following the principles of the real world, because in the example of rectangle and square, it doesn't work very well in code. In the real world, yes, because a square is a rectangle, but in object-oriented programming, a square must have the same width and the same height, otherwise it's not a square. So we must remember that when designing our classes, we must design for the context of object-oriented programming. As you could see, the Liskov principle is very important to avoid tricky bugs, because if we follow a consistent contract between classes, then it's much easier to maintain and to change our code or add new features as well. And the other crucial thing is to remember that learning something new is not enough. You need to use this concept on your day-to-day job. You need to use this concept in a real project. Otherwise, the knowledge is useless. And I also invite you for the free webinar I'm gonna do to help you to become a highly paid Java developer in 3 months on the 27th of June. So I'm gonna leave the link here below, and I invite you to register for free, and I'll be waiting for you there.